The European public network operators are currently introducing the Integrated Services Digital Network, or ISDN. This network will replace the existing analog telephone network. The philosophy of the ISDN is to offer a single network to the customer, which is capable of supporting traditional and new telecommunication services. ISDN provides the user with access to a range of services such as digital telephony, high-quality facsimile, video phone, and inter-computer communication. For all these services, only one cable needs to be installed at the user's premises. Due to the pace of technological advancement, narrowband ISDN is already outdated before it has been fully introduced. The bandwidth offered restricts the range of services which are available. The quality of a video phone picture illustrates the limitations of the network. Developments in the computer industry are leading towards the introduction of multimedia applications, where high-quality voice and video are combined. A network is required which can support not only this high-bandwidth multimedia information, but also all existing narrowband ISDN services. The broadband ISDN is the solution. The broadband ISDN has been designed to be flexible and capable of transporting all existing and many future services. The available bandwidth overcomes the restrictions experienced with narrowband ISDN. Broadband ISDN is more than 2,000 times faster. This makes even the transport of high-definition television possible. A new technique, the asynchronous transfer mode, or ATM, has enabled the broadband ISDN to be developed. ATM can combine data from different sources for transmission over the same cable. For example, the same transmission infrastructure can be used at the same time for a telephone conversation and for the transmission of TV pictures. The flexible nature of ATM arises from the way in which data are transferred. Information which a user wishes to send is chopped up and packed into small containers called cells. These cells are sent at high speed, one after the other, over the network. In the case of a video phone connection, some cells will contain the speech data, and other cells will contain the video data. Each cell has a label, referred to as the cell header, which instructs the network where the cell should be routed to. The header also enables the receiving terminal to distinguish the various types of data. Within the European community, a research program has been set up to accelerate the introduction of broadband networks in Europe. RACE, Research into Advanced Communications in Europe, is the name of this program, which was initiated in 1988. The BUNI Demonstrator was one of the most ambitious projects of the RACE program. It brought together results from other RACE projects to form an integrated broadband network. A large number of European companies, representing a wide sector of industry, were members of the BUNI project. The BUNI project has taken its name from the interface, which was the key issue in the project. The Broadband User Network Interface, or BUNI, is an important boundary for a public network. This interface is the dividing line between the equipment of the network operator and the equipment of the customer. For a successful introduction of broadband ISDN, it is essential that this interface is correctly specified.
We have to specify this interface very clearly to ensure that equipment, when it's connected together, will interoperate correctly.
The BUNI project has played an important role by providing implementations of the emerging specifications. A protocol reference model is used to illustrate the protocol layers which are present at the BUNI. International standards organizations such as the CCITT and ETSI are currently working towards an internationally accepted version of these protocols.
idee van de EEG om de Europese bedrijven te stimuleren en om zo een technologische voorsprong te geven. Dus een van de projecten is het BUNI Demonstrator.
The BUNI Demonstrator project has brought together equipment to form a single network. The various user environments in which broadband technology will be used are illustrated by the network. One of the situations demonstrated by the BUNI network is the television studio environment. The bandwidth offered by a broadband network is sufficient to transport TV and HD TV signals. In the BUNI project, equipment was integrated to illustrate how television can be distributed to a number of customers. Broadband technology has a lot to offer to the business sector. Within a business premises, a single network can be used for both telephony and for the interconnection of PCs and workstations. All sorts of multimedia information can be exchanged. Via the BUNI, business users can gain access to the public network. A broadband network can bring a wide range of services to the user at home. High-definition television and video on demand are just two examples. One of the major components of the BUNI network is the broadband customer premises network.
The system is based around a series of terminals or local routing centres which are linked together via a passive optical fibre network based around a central star coupler.
The network is designed for use in a television studio. TV signals coming from, for example, a camera, can be routed to a number of destinations, such as a video recorder. The network is designed to be completely flexible. Any source can be routed to any destination. Another major component is the domestic customer premises network. This network illustrates the sort of services which will be offered to users at home. Both HD TV and conventional TV are available. A surveillance camera enables the user of the system to check the outside of his house while seated in front of his television.
It intends to be an integrated broadband communication environment in which ATM and SDH is used.
In order to transport HD TV signals over the public broadband network, compression techniques must be applied. Two HD TV compression systems were integrated into the BUNI Demonstrator network. After compression, the bandwidth required for the HD TV signal is considerably reduced, and therefore suitable for transmission over the public network. The decoded picture does not show any loss of quality. The ATM switch routes the ATM cells from their source to the correct destination. By looking at the cell header, the switch is able to determine where to route the cell. Specially designed control equipment enables the switch to be automatically configured.
Daniel has entered now all the parameters characteristic for a narrowband ISDN call.
Test tools were developed in parallel with the rest of the BUNI equipment. Emphasis was put on testing the complex signaling protocols which are required at the BUNI.
It was a routing and distribution system for a major studio production centre. However, the network was designed in such a way that it could be used anywhere where a large quantity of broadband data
The BUNI Demonstrator network was integrated at the premises of PTT Research in Leidschendam, the Netherlands. Extensive demonstrations were given to visitors coming from a large number of countries.
HDTV is in principe een dienst die heel veel capaciteit heeft.
The aims and objectives of the BUNI Demonstrator project will be continued in the form of Tribune, a race Phase 2 project. Tribune will further the work on the specification of the broadband user network interface.